Um, if I go too fast or you need something else, make sure I know. All right. So calculators, right? Um, just go with it. So evaluate the very first one. Surely I would hope that that was easy for you. I turn everything to exponents. So 2.56 to the, is that the cube root? 1/3. Y'all, 1/3 power is the same thing as a root, right? Denominators are roots, numerators are powers, power lines, roots, right? So just that should be just a quick punch and go. Same with the next two. So who did this and what answer did that go to? Is that the answer? 1.36? 1.384. 1 point. So is that the bottom right? No. 2.17 to the 0.35. 1.311. I don't think that's any of these answers. It's not. So it must be the last one. Parentheses 17, 20 to the -2. 1384. That's the last one. Bottom right. So bottom right, that number will put a 2. Finally, average rate of change from 3.3 to 5.8. My bet, because you need to plug both of those in, I'm going to go y equals. If I have to plug more than one thing in for x, I go to y equals. Anytime I plug more than one thing in for x, I go to y equals. 0.5. 0.5 x to the third. Thank you. 3.7. Oh, minus 3.7. Whoops, that's not a power. Ah! I'm doing as bad as you guys, son. Get over there. Get back up there. Delete. Good enough. 3.7 x squared. X squared. Everybody okay? Good. If you have the CE that's somewhat updated, alpha trace brings up y1, y2, y3, y4, y5. And I just put that in y1. So if I go enter y1 and then I do a parentheses, that's like f of x. So f of 3.3. There's other ways to do this, but if I plug in 3.3, that's what I get. And if I plug in 5.8 alpha trace, notice that trace, you can do fractions, functions, matrix. So if you want fractions, whoops, too fast. There's fractions, numerator, denominator. I forgot. Oh, that's like a mixed fraction. 1 2/3, 1 2/3, whatever. That does, anyway. There's functions, matrix. We won't do matrix. So there's the y bars. Sorry, I didn't go over for the y bars. It just stays up there. 5.8. 5.8. Good. And so then I need to do y minus y over x minus x. Second answer minus, plus, how about that? Plus 22.3245. I should have put that in parentheses, and I forgot to. So I'm just going to hit enter, and then divided by, I'll put this in parentheses, 5.8 minus 3.3. There's the average rate of change from those two values. middle left. You need to be efficient with your calculator. The faster you can work it, the faster you can do things, the more efficient you're going to be on the test. Calculators run out of time for students because they don't know how to do them efficiently. They sit there and they spend more time trying to figure something out on how to do it on their calculator. If you don't have alpha trace, then you can just simply go to, it's under math and it's under, I forget where it's at now. Not math, I guess. Oh, it's second something. Second. I forget where that's at. VARs. It's under VARs. Yeah, it's under VARs. Y VARs. Function. Y1. There's Y1. VARs. VARs is kind of like a copy paste type deal. That changes your window, changes zooms in. I don't know what that does. Picture and background. There's some statistics. There's a table. There's a string. Most of that you'll never ever use. Here's functions. There are parametric functions. There's polar functions, and there's turn them on or off. So pretty much we're doing everything here. Color. If you got color, you don't need to go VARs. That's for the older 83s and 84s. All right. Find the point of intersection of those two functions. You got to know how to find point of intersections. Okay, so I'm at that middle here, number 3. So I'll put y1. I'll put that function in there, which is x squared plus 2. X squared plus 2. And then I'll put the second one in, which is 3.5. 3.5 minus x cubed. X cubed. Okay? And then I'm no telling what my window looks like. Mine's a normal window. But good. I can see the point of intersection. Your job is to make sure you can see that point of intersection. If you can't see it, you got to move your window around to where you can see it. And you just go to window and start changing your x mins and x maxes. I might even change it now because I know that it's too big. -5, 5. I always leave those ones. And then there's y min, y max. And I always leave those ones, and I don't ever change that stuff. And so that helps me even zoom it in just a little bit more. And I can change my y's to maybe, I can change my y's, whatever. You don't have to. As long as you can see it, you're good. Okay? Point of intersection. Now we got to, all this stuff is dealing with graphs. So second, don't do trace. Don't do trace. You're not going to get the right answer. You will not get the right answer. Don't do trace. Second, calculate. I don't care about a value. Value will do like we did, like I did the second one. That'll do that too. Value 0 finds the x-intercepts. Minimum finds our minimum values, right? Maximum finds our maxes. Intersection, that's what I'm looking for. dy dx is calculus, and integral is calculus, so you'll never use these until next year. So I need the intersection, okay? Well, then look to see what your calculator is asking you. First curve, y1. First curve, y1, enter. Second curve, that's why you just put everything in L1 and L2. You don't have to worry about it. It's going to do everything for you. Second curve is the red one. Okay, good. And then it wants me to guess, and there's only one point of intersection, so I don't even have to guess. I'm just going to hit enter. And there it is. That tells me the point of intersection. To advance to the circuit, find the input value of the point of intersection. So the input is the x. Y is the output. So 0.89. Uh-oh. Where's that at? What did I do wrong? Oh, gosh, my eyes are horrible. So 2.79. 2.79. 2.79. Gosh, there's a bunch of them close to that. There it is, upper right. Thank you. There's another plug and chug. Another plug and chug. And that one, because you only want one, you can plug it right in or whatever you want to do. I still do Y1 because it's less chance of messing up. I still do Y1, and then I'll either do value or you'll do alpha Y1, or whatever you feel comfortable with that. Okay? I guess I need to do it to figure out what the answer is. Anybody do it and find the answer? Anybody? 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 The answer to, I don't know what number I'm on now. 5.818. Good. So now I'm in the upper left. This is very common too. There's two ways to do this problem. Two ways to do this problem. I'll show you the easier way, what I think is the easier way, and it's the way that I'll do it most time in class. You got a g of x, and you got, whoops. Oh, find when g of x is equal to 7.8. Let me do this. I don't want to do this. I'll do this. I got too much stuff going on. If I do it over there, I can't see it. So there's two ways to do this problem. You decide what's easier. I really don't know. I'll tell you what I think is easier, but again, everybody's different. Pop up. Come on, 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 come on. Come on. Come on. Today. It probably put it on the other screen. No? There it is. Patience is a virtue. I don't have it. 2.3x to the squared. Got my glasses. I want to put them on. I want to find out when that's equal to 7.8. Okay? So there's two ways to do this. Put that in Y1, put that in Y2, and see where they touch. To me, it's easier to move that 7.8 to the other side and set it equal to 0 and find the x-intercept. And if I move it to the other side, now it equals 0. And somebody said yesterday, they said, so now I'll factor it. No, you don't have to factor it. It's a calculator question. Don't factor it. Plug it in there and see where it touches the x-axis. And that's a little bit easier than trying to find that left, right, boom, 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 boom. Especially if that number was like 680. If that number was 680, now you got to have a y value of 680, and you got to change your window all up. With 0 and x-intercepts, you don't have to do that. You should know that there should be 2 x-intercepts. Right? There should be 2. So you want to see them both. You want to see them both, and then move your window around until you see them both. But to me, that's a little bit easier than trying to find the intersection of 2 lines. I mean, you're still finding the intersection of 2 lines. You're just finding the x-intercept. Okay with that? I'm just going to go through them now. Bottom left. Bottom left. Where'd my calculator go? Oh, there it is. Bottom left. I've got y equals clear, clear. Make sure those plots are not on. If those plots are on, you're going to have errors. Turn plots off. You don't want plots on yet. 1.13 you will. I don't know if that's the number or not. 2x, I'm bottom left again. 2x cubed. 2 didn't go. 2x cubed minus 3x squared minus 5x plus 1. On the closed interval from negative 1.6 to positive 2.6, I'm going to change my window to negative 1.6 and 2.6 because it's a closed interval, so I don't care anything else about that. What is the absolute max of the function? And so I'm going to hit graph, and I'm going to look at it. There's a turn, there's a boom, there's a turn. So now you got to figure out if that point is a max or that point a max. Okay with that? Because that would be the absolute max for that. So what I will do is I will first find that max by doing second calculate max for, it tells me the left bound, so I got to put this little cursor to the left of that max. Two ways to do that. Move it or just type in a number. -1. It's easier to type in a number. Notice it puts my line to the left of it. I know -1 is to the left of that. Now it wants my right. I know 0 is to the right. I'm going to just type in 0. It's easier to do that. It didn't do it. Oh, yeah, it did. Guess. I don't have to guess. Okay, there's the max, 2.51. I got to remember that, 2.51. 2.51, because this could be the max and it almost looks the same. So now I'm just going to do this, 2.51, 2.51, 2.51, 2.51, alpha, trace, y1. What was that, 2.6? Right? Whoop, whoop, whoop. Boom. That's my max, 2.6. I'm just going to plug it in and see what that is. 2.87. That's the absolute max, because that's higher than the curve. Okay with all that? I checked the curve, and I checked the max over here. And this was taller than this one, so that must be the absolute max. And you can do that on the graph. There's several ways that you can do it, but just to kind of show you different options, right? I could have gone, let's see, second, calculate value at 2.6, which would have done it. That may have been better. I don't know. Okay. I think that's good. Let's do bottom. Let's see. Hold on. Yeah, that's just a bunch of subtraction, increasing, decreasing. Find the zeros. You should be good. Let me just leave this function right here. I'll just leave this one. Find the zeros. Second, calculate zeros, 2. And it asks for the same thing. Left. So make sure, if I want this 0, I'm going to go to the left of it. I don't know what it is. So I'll just put it there. What was this? 1 point? Doesn't matter. See how moving it takes a whole lot longer than just typing in like negative 1.5. There, I got it. Good. Right bound 0. Guess. There's the 1, 0. That's this one. That's not the one that's on the paper. And then you got to do it again to find the next one. To find the next one, you got to find the other 0. Put it to the left, put it to the right. And then to find the other one, you got to put it to the left and put it to the right. TIs are horrible at that. Desmos is a lot easier on that way. I think you can just go to them. My numWorks calculator just goes to them. All calculators go to them except for a stupid TI. Yeah, because I can't. Okay. I think that's really all you really need for that kind of stuff. Average rate of change, decreasing, increasing, find that, find that. Beautiful. Okay. This is what you're going to, let me